Okay, so question 1, let's write a function and a table. So just make sure in the domain nothing is repeating. So let's go with -2, -1, 0, 5.5. Who really cares? Then for the range, the output, again, it really doesn't matter because the domain, there's nothing repeated. So we could have something like this. Even the range could have something repeated. That's fine. It's all about that domain. So something that's not a function, and this is where I got to watch out for. As soon as I have in the domain an x value that's repeated, I got to start looking at then what's happening in the output. Oops. So by giving something like this, 6 is going to 7 and 6 goes to 8, it cannot happen. 6 connect to both 7 and 8. So this is when we say it's not a function. If I had something like this, where 6 went to 7 and 6 went to 7 again, basically it's like somebody copy-pasted 6, 7 all over again, then that would be fine. That would still be a function because 6 is going to 7. Yes, it's weird because it's written twice, but because 6 was going both to 7, that would have actually be considered a function. Okay, number 2, create a graph. That is a function. It can be whatever you want as long as it passes the vertical line test. I'm going to take the absolute value graph we've been looking at. That works. A quadratic graph. That's a function. Whatever you can do to make it so that's a function, this is a function, okay? So it passes the vertical line test. There's more than one answer here, okay? So I'm going to do that. Well, that's not a function, something that fails the vertical line test. There we go. It fails the vertical line test, that's not a function. Could be a circle. We've seen a circle a few times, okay? So whatever you want to do, could be a square even, that's not a function. Solve and graph the inequality. Solve the inequality just like you're solving an equation. Got to first get x by itself. So I would add 7 to both sides. And when I add 7, watch your signs, -2 plus 7 is 5. Now that x is by itself, remember graphing on our number line, I go to 5. 5 is closed because of the or equal to, and it says less than. This is less than or equal to. So I'm going then to the left, okay? Two-step inequality. First I subtract 3. 3 minus 3 we know is 0. Divide by 2. X is greater than 0. So this is read as is greater than. Now again, these two examples, or these two homework problems are all reviewed. This is stuff you've done in many years ago in your middle school over those last couple of years. Number 6, if it's a function or not. So quickly, let's go through and determine here, passes the vertical line test or not. This is a no. This is a yes. This is a yes. Now to write the domain in the range. The domain here, one more time, domain focuses on the x's. The range focuses on the y's. So what I've been telling my kids is think of like bookends. Does it stop on the left? Does it stop on the right? We read a graph from left to right, and it does on the left. It does on the right. There's no arrows there. So from that, my domain is from -3 to +3. Whoops, sorry. I forgot something in the middle there. From -3 to +3. Now, after that, I'm going to put an equal to underneath each one of those because right here, it is all solid. Right here, it's a solid point. It's not open. For the range, I think of floors and ceilings. There's a floor and a ceiling here. It's not going below -2. My graph does not have any arrows going down. My graph does not have any arrows going up. So the range is from -2 all the way up to 4. And because of that, from -2 to 4 like that, they have equals underneath because down here it's a solid point, here it's a solid point, they're not open. Letter B, Okay, for the domain, it's on the x's. Now, there's an arrow there. So because it's an arrow, this arrow pushes through this kind of left bookend and continues on that direction. On the right-hand side, same deal. That arrow pushes through that right bookend and continues on. So I do not stop on the left and the right. I continue on for what we call all real numbers. And another way you can write this that you will also see is from negative infinity to x, and then on to positive infinity. Infinity never gets an equal to underneath of it because infinity does not stop. When you put an equal to there, it's like you hit a wall, but we didn't. Those arrows told me continue to open out. The range is the y's. I'm looking for floors and ceilings. I have a floor. It looks like I have a ceiling, but because this arrow pushes right through there and it continues up, 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 and up. Now the floor is still there, and the floor says I want everything above 0. So to say everything above 0 is greater than, and I'm going to use also an or equal to underneath there, because right here where the graph starts, right there, those are all solid. So I'm going to keep that as an equal to. Letter C, the domain is x. Now here, this one does not go out to negative infinity. There's no arrow there. So we do have like a wall, like a left bookend, starting there at -5. And then to the right-hand side, looks like we have a wall, but there's an arrow, and that arrow pushes right through that wall, that bookend, and it continues on. Where does it continue on to? It continues on to infinity. Now I come back to -5, and I put an equal to underneath of that, because right here where that starts, it's a solid piece of the graph, and that always gets a close. It gets a or equal to underneath. Now infinities never do, because infinities will not stop. The range. I'm looking for floors and ceilings. And I have a floor here. I have a ceiling here. It's staying right in between that interval. So with that in mind, with that floor down here at -4, and then that y up there, that ceiling up there at -2, I'm staying in between for the y's between -4 and -2. Now, because at -4, that's all solid, and at +2, that was a solid piece of the graph, I'm going to put that equal to underneath each of those as well, okay? All right, 7, function or not. Looking at the domain right here, I need to see more than one line coming out of it, going to a different y value, and we are good to go, so that's a function. Letter B, looking at the x's, the domain, we are good to go. That's a function as well. If, say, 3 was also going out to 4, or sorry, I drew it to 2. If 3 was also going out to 4, 3 cannot go to 10, and then 3 cannot go to 4. That would be not a function. But we do not have that, and we're good to go here. Oof. Okay. Letter 8, number 8. We've seen the parabola, okay? That's a function. Domain is the x's, range is the y's. I keep kind of talking about this idea of left and right bookends, which we do not have because the arrows push right through the bookends, those walls. So we are going from all real numbers. Another way you will see this written is -infinity to x, x to infinity. For the range or the y's, I'm looking for floors and ceilings. I got a floor, but I do not have the ceiling. The arrows punch right through that ceiling. I want everything above -2. When I say above -2, that means is greater than -2. And I put an equal to underneath of that because right here, that minimum, it is solid. Solid means or equal to. Letter E, it is a function. Passes the vertical line test. And right then, for the domain, okay, it looks like we have bookends, again, left and right bookends, but the arrow punches right through there and it continues to do that forever. So all real numbers again. And that is going to be from -infinity to +infinity, okay? Floors and ceilings for the range. I have one of those. I have a floor. But I do not have a ceiling because those arrows, it's going to do this. That's what the arrows are going to do. So I don't have a ceiling. So I want everything above 0, okay? Everything above 0. And I'm going to put an equal to there because right here where it starts at 0, those are solid. Okay, letter F. This is not a function. It screws up all along right here. Fails the vertical line test all along there. So it's not a function. We can still write the domain of it. We didn't do this in our notes, but you can still write the domain of a non-function. X's to Y's. And here, there's no arrows. Here, there's no arrows. So the domain is staying between those values from -2 to +2. Now, +2 this time, I put an equal to underneath of that. Because, again, right here, it's solid. But we haven't come across this one. Because I have open circles here and here, this is where I'm going to leave this as just is less than. It does not get an or equal to underneath of that because it's not solid right there. For the range, that's the Y's, floors and ceilings, which I have. From -2 to +2. And because it starts off with an open here and ends with an open there, same deal. I'm not going to put an equal to sign underneath of that. So it's not inclusive then. Number 9, reading a graph. We've been looking at these before with reading a graph. The time is my domain. The range is my distance. So when I say what is h of 1, where's the point located as 1 comma what? And it's located right here at 1 comma 10. So what that means then is, after 1 hour, the distance traveled was 10 miles. Again, we've seen that. This is a review question. 2 comma 30. After 2 hours, we traveled 30 miles. At h of 5, 5 comma 70, it looks like. After 5 hours, we've traveled 70 miles. Now this next one wants us to fill it in backwards. After blank hours, the distance traveled was 50 miles. So this time we have to look at first the Y's, the range. So right here is at 50, okay, so then we're at 4. 4 hours, it took us, at 50 miles, it took us 4 hours there. So that is the domain, the independent. And then this is my range, the dependent, okay? The distance is dependent on the time traveled. Same thing on this one. Now here, reading this, I was given the output, the range at 40. So, which is right there. So that means it was 3 hours. After 3 hours, I traveled 40 miles.